Welcome to today's class. Today we'll be looking at how to solve problems in progressive wave equation. We have a problem right on the board, and then this problem deals with progressive wave equation. Then the question is, a progressive wave equation is represented as y equal to 150 pi t minus pi x over 4 in brackets. If the phase difference of a progressive wave is 45 degrees, find the value of x. So first of all, you need to know that the question involves progressive wave equation, and then we are given the phase difference as 45 degrees, and then we are asked to find the value of x. Now, before we go on to solve problems in this question, before we go on to solve this question, you need to know that in progressive wave equation, that there are basically three formulas, not less than three formula, that can suit each equation that is being given to you in progressive wave equation. First and foremost, you could see that there is an equation that was given in this question, and this equation that is given is y equal to 150 pi t minus pi x over 4. Now, what you need to do is to write down this equation out. You write it out. So you have y equal to 150 pi t minus pi x over 4. Then in brackets, okay? In brackets. So I've written it out. That's the first thing you need to do after reading through the question. So we've read through the question, and then we understood that the phase difference was given, and then we actually find the value of x, and that this question was pertaining to progressive wave equation. Then I said previously that there are no less than three equations that can be used to resolve problems in progressive wave equation. So what we'll be doing is to write down these three possible equations, and then we'll now know the one that can be able to suit the problem that we have on the board. All right, so we have the first one, which is y equal to a sine, then we have theta plus or minus, then your phi. Now, this is your amplitude, this is your sine, this is your angular displacement, and this is your phase difference. Then we also have y equal to a sine, then wt plus or minus, then you have your kx. Okay, so this is your angular velocity, this is your time, this is your phase number, and this is your displacement. And then we also have y equal to a sine, and then you have 2 pi ft plus or minus 2 pi x over lambda. Then you have this. So these are the three possible equations that can be used to resolve problems in this. All right, so now look at this. So we have this, and then we have this, we have this, we have this. So this is the question, this is the equation that was got from the question that was given. So if we have this now, which of these can suit the solving of this problem? Now we are given the progressive wave equation, the phase difference as 45, and the phase difference, the symbol is this, which is 45 degree, and then we're asked to find the x, which is not given. So if we look at each of these equations, you agree with me that the best equation to use here is this equation. So we'll map it out. So that means I'll be using this to solve this problem. So the next thing we need to do is to wipe this off. All right. So we've wiped it off. Then what's the next thing we have to do? The next thing we have to do is to compare the given terms. So here is your phase difference, okay? And then this is the aspect that goes with the phase difference. All right. So what we need to do is to copy this out, and then we have this. The phase difference is equal to pi x over 4. All right. So the phase difference is equal to this. So if we have that the phase difference is equal to this, then we can then start solving. All right. So we are given that the phase difference is 45 degree, and we know that in degree that the angle is 45 degree, And then we have that x is what we're looking for. We are asked to find it. So we have to put it down that this is giving us 45 degree, and our pi is 180. Pi in degree is 180. Then we have x, so x, and then we have 4. All right. So we have this now. So how are we going to be able to resolve this? So for us to be able to resolve this now, we have to use this 4 to multiply this. First of all, you know that this is equivalent to over 1. Okay, same thing as over 1. So 45 times this, you have 45 times 4, which is now equal to 180 degree, then times x. All right. So if you have this now, what's the next thing you have to do? So 45 times 4, you have 180, then 180, then x. All right. So we now have to divide through with this. We have 180 equal to 180x. So divide through with 180, divide through with 180. All right. So if we divide through now, this 180 divides this, and then this one divides this, then we'll have x equal to 1. 1. Now listen, before we add the unit, now look at this. We compared this, okay, with this with this, and then we are given in the question that this is 45 degrees, so this is 45 degree, and then we have that pi in degree is 180, so we have 180. Okay, and then we're asked to find x, which is 180 times x, and this is 4 over 4. So what we have to do is to use this 4 to multiply this 45, and then we'll have 45 times 4, and then we'll have 180. Then we have 180 times x, then we have 180 times x, and 180 x. And then we are looking for the coefficient. We are looking for x. Actually, we're looking for x. And the coefficient of x here is 180. So we have to use the coefficient of x to divide both sides. Dividing both sides with the coefficient of x, or dividing both sides with 180. That's this 180 and this 180x. Divide both sides with 180. So we have 180 cancel 180, and then 180 cancel 180. You have 1. Then the unit of x, you need to know that x is displacement. So the unit of x can be meter, it can be centimeter.